Welcome. In this video, we are going to look at the second question. But it says, given that the force is given by the formula F is equal to 6 pi, then the symbol for viscosity V, where A is the radius and V is the velocity. Now the question is, find the dimensions of that symbol for viscosity. Now here we've been given the formula to say, okay, let's look at the solutions. We have been given the formula force is equal to 6 pi, then this symbol AV, where we are told this is the radius and this is the velocity. So now, in order for us to proceed in finding this, let's make this the subject of the formula. So we make this the subject of the formula by simply dividing by 6 pi AV and 6 pi AV. So we're going to have this one and this one, this one and this one are going to cancel. What we're going to have is, so our viscosity here will be F over 6 pi AV. But as I said in the previous video, 6 is simply a constant and pi is simply a constant, which is 22 over 7 or 3.142, something like that. Now here we just have the dimensions for force and the dimensions for A and V. So here we know that force is equal to mass times acceleration, and the dimensions for mass, it is capital M, and the dimensions for acceleration, so from acceleration, from the units, we have meters per second squared. So meters per second squared, so we have meters, the dimensions of L over time squared. So these are the dimensions of force, which can also be written as M L T to the power -2. They will also have radius. We are told to say A is equal to radius in the equation, and the radius, it is actually in meters. Yeah, it is measured in meters, the SI units for length. And so from there we are going to say A, which is radius, let us not confuse this and this one. This one we are following the question to say this is radius, and this A, it is for acceleration from the force. Force is equal to mass times acceleration. So this one from the question, we have yeah, it is meters and the dimensions of L. And then velocity, we have the units, meters per second, okay, which will give us, so the dimensions for L, for meters, that will be L, and for time it will be T, which can also be written as to the power -1. So let's now try to plug in these values into this. So we're going to have this symbol is going to be our M L T -2 over. So this is a constant, this is a constant, so we have the units for radius, or the dimensions for radius, which is just L, and for V, it is L to the power T -1. So this one, we can proceed, okay, coming this way. So this one will give us okay, the dimensions for force, -2 over L squared T to the power -1. So this one is going to give us, so if you want, we can cancel this one and this one. Okay, then when this one comes up, it is going to be a positive, so we are going to have M T -2 plus, when this one comes up, it is going to be a 1. Then here we are going to have L. And when this comes up, we are going to have m, when this comes up, it is going to bear a power of -1, and t, so -2 plus 1, we're going to have a -1. So these are the dimensions of viscosity m, L -1, T -1.